Hello students, so today we will start with NEET 2025 physics paper discussion. So paper was above the level of what should the NEET exam ask, okay, but still see there are questions are not that much difficult, okay, but still if we see the time limit, okay, in that time limit it is very hard for the student to do these questions, okay. Now see, if you go by logically you will able to solve it, okay. But still for a good, you can say normal students also, it will be kind of difficult level because in NEET you expect more speed, okay, not more in depth or difficult questions, okay. So students are not ready for the difficult paper. That's why somewhere you can cut the marks, okay. The marks will decrease. Otherwise, if you understand that how to deal with a difficult paper, okay, then you will able to do. So deal with the difficult paper means leave the question when you are not getting it, okay, that's what. Now understand the first question, okay. First question, what he is saying, a parallel plate capacitor made of circular plates is being charged such that the surface charge density of its plates is increased at a constant rate with time. So surface charge density is increasing with a constant rate with time. Magnetic field rising due to the displacement current is, okay. See in this question, what he is saying, we know sigma is equals to Q by area, right? Charge per unit area, okay? Now he is saying, first of all, differentiate with respect to time. So I can say d phi by dt, d sigma by dt equals to, here charge per unit time is what? Current per unit area, okay? Now here what is this? This is, he said, constant, okay? Constant means this current is constant, means displacement current is constant. Now understand what he is saying. He is saying this is a parallel plate capacitor, okay. Here displacement current is passing, okay. Normal current is not there, okay. Displacement current is only there, right? So due to this will act like a cylinder, okay. This will act like a cylinder, and he is asking magnetic field here, how the magnetic field will be there in this region. So we know if we have a cylinder through which current I is flowing, okay, then how inside and outside magnetic field changes, right? Formulas are there for that. Directly I will tell you with the help of graph. The graph says increases linearly, right, proportional to R, and then after inversely proportional to R, okay, like this. So if you go by the here options, so here first option is there, non-zero everywhere with maximum at the imaginary cylinder surface connecting peripheries of the plate. So A option is correct, okay, maximum at the R, okay, on the surface. The main concept was you have to find out that current is constant. If current is constant, then magnetic field graph will come like this, assuming this is a cylinder, okay. So inside it varies linearly and then 1 by R relation, okay, that's it. So that's how you do the first question. Next question, electric dipole is given, okay, with a 5 into 10 to the power minus 6 coulomb per coulomb meter is aligned with the direction of a uniform electric field of magnitude 4 into 10 to the power 5 Newton per coulomb. The dipole is then rotated through an angle of 60 degree, okay, with respect to the electric field, the change in the potential energy. If you remember, we have wrote the formula minus P dot E, right? By that formula you go, minus P dot E, okay. So first initially aligned, okay, so we can write down minus PE dot product na, so cos theta, okay. So final potential, initial potential, by that you write down, okay. So finally is what? Minus PE cos 60, okay, and initially is what? Minus of minus PE cos 0, right? Aligned na, so cos 0. This is what? So now here minus PE cos 60, how much? Sin 31 by 2, or minus plus PE, that's it. So this is minus, this is, so PE by 2, okay. Put the value. What is the value of P? P value is given here 5 into 10 to the power minus 6. 5 into 10 to the power minus 6 into E. Electric field value is how much? 4 into 10 to the power 5. 4 into 10 to the power 5. 4 into 10 to the power 5 divided by 2 is there. So how much this came? 4, 2, 2, 5, 10, okay. This is 10 to the power 6, this became 1. Okay, so answer is fourth option, 1 joule. Okay, that's how. Easy, right? See, directly formula, this formula, minus P equals theta, dot product. Okay, a ball of mass 0.5 kg is dropped from a height 40 meter. The ball hits the ground and rises to a height of 10 meter. The impulse imparted to the ball during its collision with the ground is. Okay, now you have to understand that if he is asking for the impulse, then we have to go in the change in momentum. Correct? So ball dropped from whatever dropped means V equals to 0 from a height of 40 meter. Okay, and maybe he hit with the velocity v1, let's say. Okay, and rebounded with a velocity v2. So he rebounded with a distance of 10 meter, and here he got v equal to 0. That's it. This change in momentum you will find out, that is only your impulse. Okay, so your impulse is nothing but m into v2 plus v1 will come, because here minus minus will become plus. Okay, v2 minus of minus v1, that is plus v1. Okay, so this will become m into v1 plus v2. Okay, let's find out the v1 and v2. So a particle dropped from a height. What is the velocity? v1 is under root 2 g h. H is 40. Okay, I think he told to take the h, g as 9.8. We will put the value later on. Okay, just hold on. So 40, so this is how much? v1 equals to under root of 80 into g, 80g. Or v2 will come how much? If you solve for here, okay, going up to height 10 meters. So v2 will also come under root of 2g into h, that is 10 meters. So v2 is nothing but under root of 20g. Okay, this is, put the value here. So impulse when you are solving, do we have to get the exact value? See, the values are very away from each other, right? 7, 21, 84, 0, right? So we can go with the 9 point, instead of 9.8, 10 also we can go. Okay, so this is 800, this is 200, right? So m is how much? M is 0.5. Fine, m is 0.5, 1 by 2, and v1 how much? Root 800 plus v1 v2, whatever v1 v2, this is how much? 200. Okay, so I is equals to what? Here 400 is 20, so 1 by 2 as it is, or this is 20 root 2 plus this is 10 root 2. Okay, I is equals to, this is 30 root 2, right? So 15 into root 2, right? So 15 into 1.732. Okay, so 15 into 1.732, so approximately you calculate. Okay, you will get your 21. Okay, got it? So 21 answer will come. If you take exactly 9.8, 21 will come. Otherwise, if you are taking from here also 1.732, approximately take it 1.5. Okay, so 15 into 1.5, how much? 3 by 2 times, right? So 7, 21, 22 approximately, that only. So we will take third option, because all options are very away from each other. Okay, so don't have to worry about that much. Okay, see the options. Options also gives you very much relaxation. Okay, fifth option. See, fourth question. The intensity of transmitted light when a polarized sheet placed between two crossed polaroids at 22.5 degree from the polarization axis of one of the polaroids is. Okay, so I naught, he is saying I naught is the intensity of the polarized light after passing through the first polaroid. Okay, see, some of the student may have not understood the even questions. Okay, he is saying two polarizers are there. Okay, polaroids are there, those are placed at 90 degree with each other. Okay, and then in between them there is a sheet is placed. See, transmitted light when a polaroid sheet, okay, a sheet is placed between the two cross polaroids. So two cross polaroids are there, and you placed a polaroid sheet also. Okay, so total 3 are there at a 22 degree angle from the polarization axis of one of the polaroids. So first you take, okay, from first polaroid you place at 22.5 degree, you placed your polarized sheet. Now understand this question. So first you have one polarizer. Okay, after passing through that, I naught is coming. That's how we defined the I naught. Okay, this is I naught is coming. Now your sheet is there. Okay, at an angle of 22.5 degree. So through this, passing through out of this, how much will be the intensity? I know I naught cos square theta, where theta is nothing but 22.5 degree. Okay. I naught cos square theta. We will calculate the value later on. Okay. Now you have another Polaroid. Okay. So we know with this it was making 22.5, and this are perpendicular to each other, right? So between this and this, what is the angle? This is, let's name this first. This is S and this is 2. Okay. So between 1 and S sheet, your angle was 22.5. Okay. And this 1 and 2 are perpendicular to each other. Okay. Crossed means perpendicular. Okay. So this sheet and this 2 will have what angle? You can say 90 minus 22.5. Right? Correct? So I can say what? Through this, when light will pass, it will say I naught cos square theta, that was already there. This was intensity. Okay. Multiply by cos square, here 90 minus theta. 90 minus theta. Okay. That's how you write down. So 90 minus cos of 90 minus theta is sin theta. So I can say this is what? I naught cos square theta sin square theta. Okay. Now either you put the value of 22.5 here, 22.5 here, solve, or you apply this formula of sin to theta. Sin to theta, how you will apply? See. Here I naught, okay, and then after here completely like this you write down 2 cos theta sin theta divided by 2 whole square, like this. Okay. 2 divide 2 multiply. Okay. 2 cos theta sin theta is sin 2 theta. Okay. So how much this came? I am writing this side. So you can say I naught into I naught, this will become 4, I naught by 4, and this will become sin square 2 theta. Okay. So 22.5 into 2, 45. Sin 45 how much? Sin 45, 1 by root 2. So 1 by root 2. So this square will become 1 by 2. So answer will come how much? I naught by 4 was already there, and this is 1 by 2. Okay. So this will become I naught by 8. That's how. Okay. Otherwise you can go with the cos. This is cos square theta, right? Go with the formula of cos 2 theta. Then in sin square theta also go with the formula of cos 2 theta. Okay. And then you will get. Okay. Otherwise do it like this. It will be more faster. Okay. Some people have put the values here and then solved. That is also okay. Until unless you don't make any silly mistake. Otherwise you go with this method. You will get I naught by 8. Okay. I naught by 8 means first option is your answer. Okay, that's how. So confusion was this only, that how many Polaroids are there. Okay, so 2 Polaroids are there, 1 Polaroid sheet is there. Okay, and angle is also little bit confusing, can confuse you possibly. Okay, next, 5th question. Kinetic energy of 2 similar cars A and B. Okay, kinetic energies are given, means half mv square, half mv square is given. On applying brakes, car A stops after 1000 meter. Okay, and car B stops after 1500 meter. If FA and FB are the forces applied by the brakes on car A and B respectively, then ratio of FA and FB. Braking force is given FA and FB. Okay. So actually this braking force is only taking this energy of the kinetic energy, right? So this kinetic energy, you can write down the work done by the frictional force, work done by this F force, right? This F into D. This is negative work done, and final kinetic energy 0, initial kinetic energy whatever K. Okay, for both of them you will write down like this only. Okay, so this is for A, this is A. Okay, so you can say what is that? FA into D is equals to KA. Okay, like this. So DA is there. Okay, both are given. Okay, this is work done by frictional force equals to change in kinetic energy. Okay, work done by that force equals to change in kinetic energy. There is one force only. Okay, that's it. So by this we write down this thing, and for the second one also you write down like that and divide both the equations. So FB dB is equals to KA by KB. Okay, so you want what? FA by FB you want. Okay, and here you know 1500 meter, A is 1000 and 1500. Okay. So this is FA by FB you want into this is 1000, this is 1500 is equals to KA. KA is given 100 and 225. Okay. So this is 100 and 225. Okay. Now cancel out 0, 0, 0, 0. This is 2, this is 3. Okay. This is 50. Okay. And this is 3. 3 times if you cancel out, this is 21, 7. 7, and then this is 115, 5. Okay, 75. So 50, 75. This is 2 by 3. I think 2 by 3 is your answer. FA by FB. Yes, 2 by 3. Fourth option. Okay, that's it. So how we did? We did with the help of work energy theorem. Work done by frictional force or whatever braking force is equals to change in kinetic energy, final 0 initial, final is stopping, right? Final 0 initial Ka. Okay. Similarly, you write down for B also and divide both of them. Okay. That's how answer will come. Easy question, right? Next, 7th. Here by look it is looking difficult, but actually this is very easy question. Okay. If you see here, see. This is 6 ohm, okay, this 5 and this is 3, 1.5. I think they have not put here, this will come 2.5, okay. So this 6 is actually becomes your, here it becomes your Wheatstone bridge, okay. It becomes your Wheatstone bridge. So here this 1 by 3, this is 6. So let's draw this circuit. Actually this is 3, half, 5, this is becomes 2.5. This is 2.5 here, okay. They didn't wrote it. Question mistake. Fine. Let me draw it correctly. What you have here is Wheatstone bridge. So in that you have here 5 ohm, okay, and this side you have 2.5, okay, 2.5 ohm, and then you have 6 in middle. 6 ohm in middle, okay, and then you have here 3 and 1.5, okay. This is 3 ohm and this is 1.5 ohm, okay. That's it. Next, what here also there are more resistance are there, 1.5, 5.5 and 1 by 3, okay, 1.5 ohm, sorry, 1.5 ohm, okay, here 5.5 ohm, okay, here 1 by 3 ohm, okay, and there is a battery 5 volt, okay, 5 volt, okay, fine. Calculate the equivalent resistance. So we see here there is a Wheatstone bridge 5 by, this is 2 factor, here also 2, okay. So this 6 will go out. Now what you have, 2.5 plus 1.5, okay, series connection. So how much? This gone, right? This gone, so 2.5 plus 1.5 how much? 3, 4, and here you have how much? 8, okay. So these are now in parallel. So it is like this, 8 and this side 4, right? So you will have 4 into 8 by 4 plus 8, right? So this is how much? 4 into 8 divided by 4, 12, right? So this is 3. This is 8 by 3, okay? And here, now this complete resistance is 8 by 3, right? So I will draw here 8 by 3. So this is nothing but 8 by 3 directly. 8 by 3 ohm, okay. So 8 by 3 plus 1 by, now this all are in series, right? So 8 by 3 plus 1 by 3, 3, okay. 8 by 3 plus 3, 1 by 3, okay. 9 by 3, that is 3. 3, and this is how much? This is 6, 7. 7 plus 3, 10, okay. So total resistance is 10 ohm, okay, in the circuit. So into I equals to V. So I is equals to 1 by 2. V equals to IR, okay. I equals to 1 by 2. So that's a 0.5, okay. That was, he is asking, fourth option. Got it? So equivalent resistance you have to calculate, that's it. Answer will come, okay. So there you have to see that this is Wheatstone bridge only, okay. That's it. Question number 7. 3 identical heat conducting rods are connected in series as shown in the figure. The rod on the sides have thermal conductivity 2K, while that in the middle have the thermal conductivity K. The left end of the combination is maintained at temperature 3K and the right end is at K, T. Okay, 3T and T temperature maintained. The rods are thermally insulated from outside. In steady state temperature at the left junction is T1 and that at the right junction is T2. So T1, T2 you have to find out. Okay. Not that much difficult, kind of, you can say little bit you have to understand. Obviously you have to understand. Okay, 3t, and then you have here 2k, all are identical. Okay, here k and here 2k, so area of cross section and length are same. Okay, here T temperature maintained, and I think this is only saying, and on the left side is T1 and right side is T2. Okay. Here T1 and here T2. That's what. Okay. Now he is saying T1 by T2 or T2 by T1. T1 by T2 he is asking. For that, understand. First calculate the equivalent resistance here. Okay. So what would I say resistance R1? Here if I call this R1, R2, R3. Okay. Okay. Then what we will call the R1. Okay. So R1 is what? L by K, right? So length is L, okay, and K is 2K into A. Okay. R2 is how much? Resistance is L by KA. K is K only. Okay. And R3 is L by 2KA. Okay. Now understand. Now if I name this L by 2K as R, so this will become 2R. For my simplicity I am mentioning this. Okay. And this will become how much? R. Okay, this is R, so this is twice, so that's why 2R, and this is R. So actually this is R, this is 2R, and this is R. Why I am mentioning like this, I will tell later on. Okay, for my simplicity I am doing this. Okay. Now understood? So okay, this thing I think you have understood. I will put it below. Okay. Shit. This is very little bit error kind of thing, you can say. Okay. Now see. Okay. See here. Now R to R. Okay. T1, T2 is there. So how we will solve this? See. First of all, dq by dt you calculate now. Dq by dt. So dq by dt will be all passing through all same only, right? Dq by dt is what? Delta t. That is how much? 3t minus t. Okay. By R. Equivalent resistance is how much? In series na. So directly add R plus 2R plus R. 4R. Okay. So this is nothing but t by 2R. This is dq by dt. Okay. Now this dq by dt will pass through this also same, through this also same, and through this also same. Okay. That you have to use. Okay. That's how we solve series and parallel connection. This is nothing but that is thermal only. Okay. Ohm's law in the thermal, right? dq by dt, the current equals to V by R. Okay. That's it. So this is dq by dt current. Write down here in this portion. Okay. Now you have to get the T1 and T2 na. So write down this in this portion. Same dq by dt in this portion. If you write down, what you will say? 3t minus t. 3t minus t1, okay, divided by resistance. Resistance is how much? R. Directly I am writing R here. That's why I used R. Okay, for convenience. Okay, so dq by dt is how much? T by 2R. Okay, so use that. T by 2R is equals to 3t minus t1 by R. Okay, so from here if you solve t1, this is t by 2, this is 3t minus t by 2, 3t minus t by 2, 3 minus 1 by 2, how much? 2 by 5, sorry, 5 by 2, 2.5 na, so 5 by 2, 5 by 2, 5 by 2t. Okay, this will come t1. Okay, t2 similarly in this you write down same dq by dt. What you will say here? Dq by dt t by 2r, which is equals to, directly let me write down here. What you will write down? T2 is bigger, right? So t2 minus t divided by resistance is how much? R only. Okay, so from here I got T2 is equals to T by 2 plus T. So T2 is how much? 3 by 2 T. Okay, this is 5 by 2 T, this is 3 by 2 T. So T1 by T2, how much? T1 by T2, 5 by 3. 5 by 3. That's it. 5 by 3, first option answer. Okay, that's it. See again how I did. You will not click otherwise. Okay. First of all, this is the given thing, T1, T2 given thing. Okay. Now we solve this thermal things according to the Ohm's law only. Ohm's law, how we solve there, find out the potential of the points, right? That way only we solve, right? So that way only I am going, and I am finding out first of all resistance R, 2R, like that you named. If you name this as R, this will be R by 2, this will be R by 2, okay? Calculation will be a little bit different, okay? That's it. So first of all, I calculated the dq by dt here, okay? dq by dt you calculated. Then after this dq by, the current passing through this, thermal current passing through this will be same through this and same through this, right? So that I applied here. dq by dt is what? This, in this one, in this portion, 3t minus t1 by resistance of this rod, R. That's it. Okay, we got the T1. In this same thing we applied, what we will write down? dq by dt, which was T by 2R, which we calculated already, is equals to delta T by resistance. From here T2 came, simple. Okay, and then you got the T1 by T2 ratio, 5 by 3. Okay, little bit of lengthy, but if you have done, then it is easy only, I think. Okay, not hard one. If you go by L by 2K, L by K, that will be little bit of I can say, for me it is confusing. Okay, so that's why I try to ignore that thing. Okay, if I am able to avoid, I will avoid, obviously. Okay, why would I make it confusion? Okay, in an oscillating spring mass system, a spring is connected to a box filled with sand. As the box oscillates, sand leaks slowly out of the box vertically, so that the average frequency omega and average amplitude A of the system changes with the time. Which one of the following options symmetrically depicts these changes correctly? Okay, first of all, if I see, okay, so how you answer, like if you have studied damped oscillation, then you can answer directly. Otherwise, go by the, what we can say, energy. Energy is half K A square. Okay, by here energy wise you go. Okay, and if you want to go with omega also you want, right? Okay, so omega also, right? So amplitude you can answer directly, that energy is reducing, right? So amplitude is reducing, directly you can answer. Okay, or go by the formula, A is equals to A naught into e raised to power minus bt by 2m. Okay, by this formula you go. As the time passes, amplitude will decrease. Okay, but this formula is for perfect damped system, where the damped force is minus BV. Okay, because here the sand is coming out. Okay, so sand is coming out, sand is getting dropped, so force will be this only. Okay, dm by dt into V. Okay, but dm by dt is not given constant. That is also one problem. Okay, so that's why directly if you see by the energy half K A square. Okay, and we see the omega. Omega is what? Under root, I can say K by M. Okay, by here you see directly. Okay, omega is under root K by M. Okay, so K is not changing, mass is getting reduced, so omega will reduce. Okay, understood? So omega will reduce. Sorry, here if M is decreasing, okay, M is decreasing, right, as a mass. Here what is happening? In this case, mass is getting dropped out. Okay, so mass is reducing, so omega will increase. Okay, omega will increase. Here energy is reducing, so amplitude will reduce. So amplitude reduce, omega increase. Omega increase. So first of all, omega increase in this option, first option, third option, and fourth option, omega increase. But amplitude we have to decrease. Here increase, constant, decrease. So fourth option. Okay, by that logic we will answer. Okay, that omega equals to under root K by M. Okay, so K is a constant, is for the spring. Okay, for the spring K is constant, but mass is reducing. So mass reducing means omega will increase. Okay, by that logic you can answer. Okay, next, 9th, AB is a part of an electrical circuit. The potential difference VA minus VB at the instant when the current is 2 ampere and is increasing at a rate of 1 ampere per second. Okay, so current rate is given. For that we can calculate here also potential difference, right? And this is minus 5 will go, and this is how much? So let's solve. Okay, okay, so directly I can say here this side VA. Okay, and then VA minus, here you can say this is L is given 1. Okay, and this current, rate of current is also given 1. Very good. So 1 into 1, and then minus 5 battery. If you jump battery, minus 5, right? From positive negative side, if you are going minus sign. minus 5. And for the resistance, you will write down IR. Potential is what? IR. So I is 2 and R is also 2. And this is giving me VB. What you want? VA minus VB? Correct. So VA minus VB, VB you bring this side, VA minus VB. And all these terms that side. So VA minus VB, you will have this is 1 plus this is 5 plus this is 4. So 10. Okay. Answer is what? 10. 10 volt. Okay. So 10 volt is answer. So second option 10 volt. Okay. That's it. Direct answer. We know this is what? Minus L into di by dt. Here direct battery is there and here IR. Okay. That's the potential things. That's it. Done. Easy question. This was very fast. Okay. Next. A particle of mass m is moving around the origin with a constant force F pulling it towards the origin. Okay. So constant force F pulling towards the origin. Okay. Next, what is saying? If Bohr model is used to describe its motion, the radius of nth orbit and the particle's speed v in the orbit depends on ns. Okay. Fine. So first of all, constant force is moving by the constant force, help of constant force, it is moving towards the center. So I can say F is equals to mv square by r. Okay. Bohr model. So mvr equal to nh upon 2 pi. Okay. That's it. Now he is saying what? That how radius and velocity depends upon the n. What power? Okay. That's it. So find out what you will say. Force is constant, mass is constant, here h is constant, 2 pi is constant, m is constant. Like that you treat. Okay. So first of all, what I want r in terms of n and v in terms of n. Okay. Go with that. So first of all, you take r. So from here, if I solve for r is some other things are constant, or you can treat like this also, mv square by f. Okay, like this. So put the value of r here. So what we will have? mv into r value is mv square by f equals to nh by 2 pi. Okay, understood? Next, mv into mv square by, so mv cube. Okay, m square constant, f is constant, h is constant, 2 pi is constant. So I can say here v cube will be proportional to n. So from here I can say v is proportional to n to the power 1 by 3. Okay, v is proportional to n to the power 1 by 3. Okay, so that's it. So from here you put here, you will get the r also. So I can say r, if you put the v here, m and f are constant. So r is proportional to what? V square. So n to the power 2 by 3. Okay, put the value of v here. So v square, so n here it will become 2 by 3. So n to the power 2 by 3. So r is proportional to n to the power 2 by 3 and v n by 3. First option. Okay, that only is asking. This answer, this is your answers. These are your answers. Okay, that's it. F force equals to mv square by r and mvr equals to nh upon 2 pi. Okay, as he said, we did. Okay, that's it. Easy question, right? Next, this is also very easy question. T equals to x square plus x. Then he is asking acceleration of the particle in terms of x. Okay, if you know the simple differentiation, okay, that we teach in 11th class basics, for the NEET also we teach. Okay, what he is saying? T equal to x square plus x. T equals to x square plus x. Generally what happens? What we say, NEET people are not from mathematics background, so they don't even focus on basics of differentiation. Okay, but they should, right? So here differentiate with respect to x, dt by dx. I want dx by dt, but hold on. Here what will come? 2x plus 1. Okay, dx by dt, that is velocity. How much? 1 upon 2x plus 1. Correct? Okay, this is velocity. Now going for acceleration. Acceleration, how you will find out? Differentiation, right? So differentiate this. So d2 x by dt square, that is acceleration only. Okay, will come how much? Here if I differentiate, okay, how will I differentiate? 1 by x. Okay, if you know directly, you can differentiate. Otherwise, fx by gx. Those NEET people, if you don't, you're not that much good at differentiation. Fx by gx, you go with that. Okay, I am going with 1 by x. 1 by x is what? Minus 1 by x square, that is 2x plus 1 ka whole square. Like this it will come. This will come, okay? And then x derivative is also there. If there was, this is not the function of t, so x derivative will also come. So dx by dt will also come. Okay? So I can say this is acceleration only. That is minus 1 by 2x plus 1 whole square, and dx by dt that we already know, 1 by 2x. Okay? 1 by 2x plus 1. Okay? So this acceleration came what? Minus 1 by 2x plus 1 whole cube. That's your acceleration. That's it. Okay? Differentiation. Answer, fourth option. Okay. Sorry, we left. I got a mistake. Here 2 will come. Next question, we have a model for quantized motion of an electron in a uniform magnetic field B states that the flux passing through the orbit of an electron in n into h by e, where n is the integer, h is Planck's constant, e is the magnitude of the electron charge. According to the model, magnetic moment he is asking. Okay. See, one thing that he is saying, b into pi r square. Okay. B into pi r square is equals to n into h by e. Okay. Then he said for the lowest one we have to find out. Lowest one means n equal to 1, h by e. Okay. This is what he is saying. Okay. If you read properly here, electron in uniform magnetic field states that flux passing through that, right? So flux you will write down like this one. Flux is what? B into pi r square. Like electron is moving in a circular path. Okay. Okay. And magnetic field is like this. Okay. So this is how you will write down. Okay. Now he is saying what? Next what? Magnetic moment. So magnetic moment is what? Magnetic moment, if you understand, the current into pi r square. Okay. So current you have to write down. So current is what? Charge per unit time. Okay. Time is what? I can say rotating in a circle 2 pi r with a speed v. So I can say distance by speed. That is the time. Okay. This is the current into pi r square. That's it. Here what came this? I can say q v by 2 pi r into pi r square. One more thing here, we don't know, right? We know he is moving in a circular path. Okay, so with the help of magnetic force, right? So what is the magnetic force? Q into, that is E only, E into VB. This is V cross B, right? But both are perpendicular already. So VB, okay, is equals to mv square by r. Okay, from here I can say if I want to get V by r here. Okay, so V by r, m you send this side, V got cancelled out. So V by r is nothing but EB by m. This actually we remember also, but still if you don't remember, this is how you can calculate directly. Magnetic force equals to mv square by r. Radius you remember, right? So from here you can calculate also. Not any issue. Okay, no issue. If you don't remember, it's okay. Here what we have? E by 2 pi into V by r. So E by 2 pi as it is, and V by r from there, EB by m. Okay. Then pi r square. Pi r square is how much? H upon E, and B also you send that side. So H upon EB. Okay. So EB cancel out. 1 EB cancel out. And here you have remaining thing what? You have EH, and here you have 2 pi m. That's it. Nothing else is remaining. EH upon 2 pi m. So that is fourth option. Okay. That's how we solve. Next 13 question. Microscope has an objective focal length 2 cm, eyepiece focal length 4 cm, tube length 40 cm, and capital D is 25 cm. The magnification is asking. So magnification formula apply. 40 length into distinct vision 25 divided by FO and FE, right? So that is given how much? 2 and 4. Okay. 2 and 4. That's it. Answer came 8. So 5, 525, 125. Okay. Answer is 125. Fourth option. Okay. That's it. This much only. Formula based question from the geometrical optics. This came. There are two inclined surfaces of equal length L, same angle inclination 45 with the horizontal. One of them is rough and the other is perfectly smooth. The given body takes 2 times as much time to slide down on rough surface than on the smooth surface. the coefficient of kinetic friction mu k between the object and the rough surface is close to. Okay, understand what the question is saying. Okay, understand. On inclined plane, okay, angle 45, okay, length is L, length they are coming down L. So downward force is there, what? Mg sin theta. Okay, so mg sin theta means acceleration is how much? G sin theta, g45, that is g by root 2. Acceleration I am writing, okay. Acceleration is how much? G by root 2. This is force downward, okay. So L distance, S is equals to ut plus half at square, you can apply. So S is equals to ut 0, half acceleration g by root 2 into t square. So t square time taken, that is t square. That's it. Next, second case, what he is saying is, inclined plane you have, same inclined plane 45 degree, but with an L length only, same length traveling. But downward you have an mg sin theta, okay, mg by root 2. But upward you also have one kinetic friction, okay. Kinetic friction is how much? Mu into normal, right? Mu k, that we are calling it mu only, mu into normal. Normal is what? Mg cos theta, 45, so same, mg by root 2. That's it. So net force is what? I can say mg by 2 root 2 minus mu into mg by root 2. Okay. So acceleration came how much? I can say divide by m. That's it. So g by root 2, that is common, you can take 1 minus mu. Okay. Understood? That's it. From here acceleration came. Okay. Now you can write down the length, same as distance you have to travel. S is equals to ut plus half acceleration. Acceleration how much? G by root 2 into 1 minus mu. Okay, into t square. Now time he is saying is 2 times. Twice of the time. Okay, here it was taking t, here it was taking 2t. Okay, that you have to understand. You can understand also. There is a factor here, normal equation. Here there is a factor coming. Okay, that is less than 1. So there should be something, this is decreasing the value. So something should increase also, because at the end L is coming, right? So here you have to put 2t. If you get confused that here it is 2t or here it is 2t. Okay, obviously here time will take more because kinetic friction is there. So it will come slower. Okay, that's why time is more. So that's it. Answer came. Okay. From this equation, divide both of them. So you will get from here and here, if you eliminate the L, okay, at least. Okay. So you will have at the end, if you eliminate, you will have 1 is equals to 1 minus mu into 4. Okay. So mu will come how much? 1 minus 1 by 4, that is mu equals to 3 by 4. That's it. Mu equals to 3 by 4. That is 0.75. Okay. 3 by 4. Got it? That's it. So it was just simple kinematics. Okay. So kinematics and little bit of NLM. Friction is there. That's how this calculated. Okay. S is equals to ut plus half a t square. Okay. Time taken more because of kinetic friction was there. Okay. That's it. Okay. Next. 15th. Okay. 15th you can solve here only. See what is happening. D1, D2 as shown in the figure. If input supply is Vm equals to 220 sine 100 pi t. Okay. Let me write down. V in equals to 220 sine 100 pi t. Okay. Here input. Okay. Then at t equal to 15, he is asking forward bias and reverse bias. Okay, fine. It will be decided by plus or minus, right? 15 millisecond. 15 millisecond means time here you put 15 millisecond means 15 upon 1000. That is the meaning of milliseconds. Okay. So V in 220 into sine of, okay, this will come how much? 100 pi into 15 by 1000. Okay. So 1000. 1220, this is 3 pi by 2. Okay, 220 into sine of 3 pi by 2. 3 pi by 2 is minus 1, right? Sine 3 pi by 2 minus 1. So V in is minus 220. Okay, minus 220 means this side negative, okay, and this side positive. Upside D1 side is negative and down D2 side is positive. Okay, so D1 will be what? I can say reverse bias and D2 will be forward bias. Okay, this side negative, upside negative and downside positive. Okay, So upside D1 side is negative na, so that's an reverse bias, and D2 side positive, so I can say this is forward bias. Okay, so fourth option. Okay, that's how fourth option answer came. Next question number 16. We have uniform rod of mass 20 kg, length 5 meter, leans against a smooth vertical wall, making an angle 60 degree with it. Okay, making smooth vertical wall, making angle 60 degree with it, means with vertical 60 degree angle is there. Okay, the other end rests on a rough horizontal floor. The friction force that the floor exerts on the rod is 20 kg mass, length is 5 meter. Okay, fine. Frictional force. Values we will put later on. First, let's solve in terms of variable. Like this wall is there. This is your rod. Okay. This angle is given as theta, 60 degree, which is given. Okay. Length L. So now put so first of all, friction is this side. Okay. And this is normal. Let's name it N2. And from the ground, normal is N1. Okay. And in the middle, there is an mg. That's how. In rotation, this is the basic question we have done already. Okay. Smooth wall, so there is no friction here. Okay. There is a friction here only. Okay. That's it. Now, balancing the force easily, I can say N1 equals to mg. Okay. And N2 equals to friction. So I get the N2, I will get the friction. Okay. Both are equal only. Right. Now, this is the balancing the forces. At one point, you balance the torque. That's it. Answer will come. So at this point I will balance the torque. So N1 and F will get eliminated because zero torque. Okay. Mg torque will balance the N2 torque. So N2 will come automatically in terms of mg. Okay. So N2 is only F. Right. So I will get the N2. So see here. About this point, if you write down the torque, what you will say? Mg into L by 2. This is theta. So this is 90 minus theta. So this is how much? L by 2 sine theta. Okay. So mg L by 2 sine theta. You can find out. Okay, this length is L by 2 sine theta. Okay, from the point, this is the line of action of force, so distance is L by 2 sine theta. This is theta, 90 minus theta, this will come sine theta. This torque is balanced by N2 torque. Okay, so N2 torque is how much? N2 into L, this will come cos theta. Okay, L cos theta. That's it. Okay, from here N2 came how much? I can say mg tan theta by 2. Correct? Okay. So N2 equals to mg. Mg is given, I think. M is given 20. And G he said 10. In this case he said 10. So 20 into 10 theta. 10 60. 10 60 root 3 by 2. So this is nothing but 100 root 3. Newton you can say. This N2 is only friction. 100 root 3, fourth option. Okay, that's it. Next question 17. Two identical charge conducting spheres A and B have their center separated by a certain distance. Charge on each sphere is Q and a force of repulsion between them is F. Okay. A third identical uncharged conducting sphere is brought in contact with sphere A first and then with the sphere 2. Okay, uncharged, finally removed from both. New force of repulsion between the sphere A and B. If radii A and B are negligible compared to the distance of the separation, so that the calculating force between them, they can be considered if the point charge is best given as. Okay. If you understand the question, it is very easy, and you can see very basic also from electrostatics. Just balance the potential, right? He is saying there is a sphere with a charge Q, another sphere with charge Q, you name it A, this is B. Okay, there is an electrostatic force that's, let's say, r distance away. They are always at r distance away. So F is equals to kq square by r square. Simple, right? Now some other third uncharged sphere came. Okay, uncharged sphere came in contact of this. Okay, so what will happen? Potential equated. So identical came, right? So potential equated, radius equal, everything same. So charge will get equally distributed. In both equally distribute, then that is only the way to equate the potential if the radius is identical. Otherwise we have equated that other way. Okay, sphere. So Q and other charge is 0. So you came in contact Q by 2, Q by 2. So new situation came what? Here on this I have Q by 2 and that third you bring, that is also having Q by 2. This is the A. And B have now what? q only. Okay, this is situation 2. Okay, now what he is saying, you bring this in contact with this. So total charge, radius is identical in this case also. Total charge is how much? Q by 2 plus q. Okay, this total charge will get equally distributed in both. Okay, so I can say when he will go in contact with it, what you will solve? You can say here A is same at q with q by 2, and B will become what? Q by 2 plus q is how much? 3q by 2, and equally distributed, so half in this, half in this. So this will have 3q by 4. Okay, that's what it will have, the charge. Okay, so these are the two charges they will have. Okay, it's separated with a radius r. Got it? So now new force that you will write down, F. Okay, F dash, that will be how much? K, q is q by 2, and on B you have 3q by 4 divided by r square. Okay, so here just factor is there, 3 by 8 factor is there, so F dash is nothing but 3 by 8, and then you have kq square by r square, that is F only. So factor is 3 by 8, 3 by 8, 3 by 8, 3 by 8, second option. Okay, that's how you answer. Okay, so this was the basic question of we have studied. Okay, so by that you can solve directly. Okay, basic question, this is in the notes, just equating the potential, making in contact, then making in other contact, and like that. Okay, next question, 18th. Two cities X and Y are connected by regular bus services with a bus leaving in either direction every t minutes. A girl is driving a scooty with a speed 60 km per hour in the direction of X to Y. Notices that a bus goes past her away 30 minutes in the direction of her motion. Okay, and every 10 minutes in the opposite direction. Choose the correct option for the period t of the bus services and the speed. Okay, speed of the bus and the separation between the buses. This was question, you can say for you it was difficult, but actually this was easy. See here how it is happening. You can say this is a 2-lane road. Okay, this is your, that girl is there going this side with, let's call it V0. Okay, okay, now what is happening? Continuously buses are going this side with V. Buses are there which is going this side also. Bus services are in both sides available. Okay, understood? Rough. Bus services are available in both sides. So when this girl is going this side, okay, what is happening? That the bus which is coming from back side, okay, that is passing her in every 30 minutes. Every 30 minutes. And the bus which is coming from front side, that is passing every 10 minutes, like this. Okay, this bus have equal separation, how much? That is equally separated with the time, capital time t. Okay, actually, okay, with respect to girl, how the girl is seeing, that is passing every 30 minutes. Okay, and here this bus which is crossing her opposite direction, that is passing every 10 minutes. Okay, understood? How we will solve is, let's assume the separation between the bus is d. Okay, originally how you will write down that d is velocity of the bus with going, let's say VB. Okay, and separation is how much, time is how much, capital T, right? So let's see, we are calculating, this is given 60 km per hour now. So let's calculate everything in kilometer per hour only. Okay, distance is in kilometer, time is in hours, right? But capital T is given in minutes, right? So we'll write down capital T by 60. This is the distance between the two consecutive buses. Okay, now this distance you will write down in another way. This d distance, okay, when with the scooty the girl is going this side, right? Okay, the bus is also going this side. So with respect to the girl, what is the speed of the bus? I can say VB minus VO. Okay, VB minus 60, right? That is the speed of the, I can say, bus. Okay, so I can say here relative speed is VB minus VO, or VG you write down for the girl, Vg. Okay, let's write down Vg. Okay, that's it. Because it is going in the same direction, so with respect to the girl, you will give in opposite direction, so Vb minus Vg. Okay, into time taken. Time taken is how much? If it is in the same direction, then she is saying passes 30 minutes. Every 30 minutes means how much? 30 by 60 hours, na? Velocity into time is distance, right? Distance is constant, right? Distance, relative distance, same only. Okay. Third way is what? The opposite side bus that is passing. Okay, that you can say what? Passing with a speed. So relative speed will be what? If this is going with Vb with respect to the girl, this is Vb plus Vg, right? So here Vb plus Vg is how much into time. So time is how much? 10 minutes, so 10 by 60. Okay, here I know the values, so I will put that value. First of all, this I know 60 and this is 1 by 2. So let's put the value. I can say Vb minus 60 by into 1 by 2. And here you have Vb plus 60 into 1 by 6. Okay. These are the three equations with the distance. Okay. What I want Vb and T, right? And that's it. That's it. Get the answer. Okay. So I have three equations in Vb, T and D. Three equation, three variable. Okay. Easy way to solve is this is D, this is D. Okay. Don't interfere the T in between. Solve these two only. So equate this D. Okay. What you will get? Vb minus 60 into 1 by 2 is equals to Vb plus 60 into 1 by 6. Right. So 1 by 2, 1 by 6. So here you can say this is 1 by 3. 1 by 3. So this side 3. Okay. So this is 3 Vb. This is 2 Vb. So 3 Vb minus Vb, 2 Vb, right? And this side 60 and plus 3 into 60, that is 3 into 60 only you keep. Okay, Vb came how much? 4 into 60 by 2. So this is 120 kilometer per hour. Okay. Vb is 120 kilometer per hour. So if I see go by the speed directly, so there is only one option, only 120 kilometer per hour. By there only I got the answer. Otherwise you put this value of Vb here, okay, or anywhere you put Vb here, you will get the D value you put, you will get the T, okay, and T will come 15, okay. So Vb by Vb only I got. If I am confident with my answer, okay, I will tick here and I will move forward, okay. Otherwise you can put, otherwise how you will solve? This Vb you put here in the first, this equation, and you get the D, okay. After getting the D, put the D value here, Vb you already put, and T you got, okay, that's it. So T will come by the option, if you see, you will get the 15, okay. It will come for sure. 19th. A container has two chambers of volume V1 and V2 separated by a partition made by an thermal insulator, okay, thermally insulated. Okay, chambers contains N1 and N2 moles of an ideal gas at temperature at the pressure P1 and P2 respectively. Okay, V1, V2 is given, P1, P2 is given, N1, N2 is given. Okay, temperatures are not given. Then the partition is removed. The mixture attains an equilibrium pressure of. Okay. See here, some of the people have me think like, I think in the notes in the KTG chapter we have question of the energy conservation, right? When you open the valve, how the energy will conserve. So here there is an energy conservation. Thermally insulated means both had the different temperature initially, right? So you can't say temperature equated, okay? That is not the way. So energy equated. So I can say F by 2 nRT, okay? Whatever degree of freedom, according to the given information, I have to assume that this N1, N2 have the same degree of freedom, right? So you will write down what? F by 2 N1 RT1 plus F by 2 N2 RT2, and finally you will have F by 2 N total into RT, final T, okay? Basically mixed, okay? So nRT is what? PV equals to nRT, always valid, right? So I can say F by 2 into P1 V1, okay? F by 2 into, this is P2 V2, okay? And this is F by 2 and total RT, right? So pressure you want to find out, P final, okay? And volume is what? V1 plus V2. That's it. That's how you will apply on whole container, right? PV equals to nRT. F by 2 cancel out, okay? So P1 V1. So P final came what? Nothing but P final is nothing but P1 V1 plus P2 V2 divided by V1 plus V2. Okay. So put the value P1 P2. P1 1 into 2. 1 into 2 plus P2 V2. P2 V2 is what? 2 into 3. 2 into 3 divided by V1 plus V2, that is 2 plus 3. Okay. 2 plus 3. How much is this? I can say 6 plus 2, 8. 8 by 5. 8 by 5 means 1.6. Okay. Multiply by 2 and divide by 2, 10 will come 6. 1.6. Okay. 1.6 ATM. Fourth option, answer. Correct? Okay. Next, see. 20th. de Broglie wavelength of electron orbiting in the n equal to 2 state of hydrogen atom is close to. Okay. De Broglie wavelength of an electron orbiting in n equal to 2 state of the hydrogen atom is close to. So n equal to 2 state he gave and Bohr radius he gave. Okay, fine. So I can say what he is asking, de Broglie wavelength. Okay, lambda. Okay, so I can say lambda is equals to h by p. Okay, okay, and I know mvr equals to nh upon 2 pi. Okay, mv is nothing but p only, na? P into r equals to nh, and he said n equal to 2, right? N equal to 2, so n equal to 2 put h by pi. Okay, so p value is how much from here? P value I can say h upon pi r. Okay, so from here you put the lambda value, so h equals to h, lambda equals to h by p. P is what? H into pi r, so pi r. Okay, so lambda is equals to pi into r. R value given? R value given na? 0.052. Put the value. Pi r came. Okay, pi r is your answer. That's it, lambda. Nothing else. Okay, pi r is your answer. So fourth option will match 0.67. Okay, that's it. Next question. 2021. To an AC power supply of 220 volt at 50 hertz, a resistor of 20 ohm, capacitor of resistance 25 ohm, and inductor of resistance 45 ohm are connected in series. The corresponding current in the circuit and the phase angle between the current and the voltage is. Okay, so we will go with what? Formula. What he is asking? Current. Okay, so current I is equals to V, that is given, I think, how much? 220. Okay, so 220 by Z. Z is how much? Under root of R square. That is R is given resistance 20, right? So 20 square plus here XL and XC. So that is what? 25 and 45. So 45 minus 25. Okay, so 45 minus 25 whole square, right? This will be your Z. Okay, from here I you can calculate. Next, what he is asking, phase. So tan theta is equals to, we call it tan phi. We call it tan phi, right? Tan phi is how much? XL minus XC by R. Okay, so XL minus XC. XL is how much? 45 minus 25. 45 minus 25. 45 minus 25 by 20, right? 20. Huh? So this is how much? 20 by 21. So phi equal to 45. Okay, phi equal to 45. I have this fourth option. So here you will solve. This will come 7.8. Okay, this you can solve. Okay, little bit of hard calculation, but still you can solve. Okay, I think 11 by root 2. As far as I remember, 11 by root 2 answer will come. Okay, you solve this. 11 by root 2 will come. Okay, not that much hard. Okay, this is 20 square, 20 square. Okay, let me solve only. 220. This is 20 square, 20 square. So I can say 20 root 2. Okay, this came how much? 20 cancel out 0 to 11. 11 by root 2, right? Okay, this will come I by 7.8 only. Okay, multiply by root 2, divide by root 2. You will get 7.8. There 45. Okay, 7.8, 45. This fourth option came. Okay, directly 45, either second or fourth will match. So 11 by root 2 means greater than one quantity in denominator, so decrease. So fourth option. That's it. I don't have to even calculate 7.8 exactly will come or not. 22. Which of the following option represent the variation of photoelectric current with the property of the light shown. Okay, property of the light, he is showing intensity and frequency he is talking about, right? So I can say intensity graph is linear, right? So by that we can say intensity graph will be linear. So A is true. That's it. Frequency is not writing correct. Okay, frequency not correct, right? So A is only correct. Is third option. Okay, third option is answer. Got it? It's up. That's it. 23rd. A pipe open at both ends has a fundamental frequency F in air. Okay. Open end, what can you say? Open organ pipe, right? So open organ pipe have a frequency F. Okay, fundamental frequency. So open organ pipe, fundamental frequency F. So fundamental frequency of open organ pipe. Okay, open organ pipe is V by 2L. Right? That's it. Now next F dash. What he is doing? The pipe is now dipped vertically in the water drum to half of its length. So length became half, okay, and dipped in water, okay, something like resonance tube, okay. So one side is closed, one side is open, right? So this became what? Closed organ pipe, okay. So now the frequency will be how much? Okay, so F dash is equals to first of all V by 4L, right? Where L became L by 2, okay. So this is nothing but V by 2L is only coming. Okay, so this is F only. Okay, so nothing, no factor is coming. Okay, this is F only. So answer is fourth option, correct. Okay, that's it. It came directly. Length is becoming half, but V by 4L because it became the closed organ pipe. 24th. Two identical point masses P and Q suspended from two separate massless springs of a spring constant K1 and K2 respectively oscillate vertically. Okay. Okay. If their maximum speed are the same, then the ratio of amplitudes is AQ by AP. AQ by AP is asked. Okay. Fine. Maximum speed is what? Omega P into AP is equals to omega Q AQ. Okay, and related to P there is K1 and related to Q there is K2. Okay, so omega formula is what? Mass is same or not? Two identical point masses. Okay, identical point masses means mass same. Okay, so omega is what? Under root K by M. So K1 by M AP is equals to under root K2 by M into AQ. Okay, so AQ by AP is asking. AQ by AP. So AQ by AP that side. Okay, so AQ by AP. Okay, this side. So root of K1 by K2. Okay, that's it. So root of K1 by K2 will come. Root of K1 by K2, second option, answer. Okay, this you have to remember here. You can confuse here. Okay, P is with 1 and Q is with 2. That's why. That can confuse. Okay, so this you have to be careful with. Okay, velocity, maximum velocity he is saying equal. So maximum velocity, I think you know the formula, omega A, right? Velocity formula is what? Omega under root A square minus x square, right? So at x equals to 0, maximum velocity by that. Okay, SHM. Simple harmonic motion, oscillation, some people called as chapter name oscillation also. 25th, output of the given logic implementation is similar to the output of an which gate? Okay, this gate we have to draw. Maybe you will not able to see very much clear here. Okay. So this is OR gate, this is AND gate. Okay, so we have one like this OR gate and then NOR. Okay, NOT is there. Okay, this we will discuss later on. So this is first of all, one input is here, one input is here like this. You have AND and then NAND. Okay, like this input, and these two are going in the AND gate. Okay. These two's input are going in the AND gate, and then output is coming. Okay, you have to draw the truth table. By truth table we will able to decide. Okay, so first of all here A, B, A. Okay, this is A, this is also A, and this is also A, and this is B. Okay, that's it. So draw the truth table. Truth table, I think you know. If you know the Everyone knows that question will come from this chapter, right? Every year comes. So A, B, and here answer. Okay. So A, B. So first of all, let's take both way 1, 1. Okay. Both way, if I take 1 here and 1 here. So what will come? 1 and B also 1. So 1 and 1. This is what? OR gate. So 1 and 1 OR gate will come with 1. But not is there. So 0 will come out. Okay. And here 1 and 1 AND gate 1 will come, but not is there. So 0 will come out. 0 and 0 in AND gate. So 0. Okay. So here answer 0. Okay, fine. First we did. Next what? If let's take in 1, you take 1 and here you take 0. Okay. So A is 1, 1 and B is 0. Okay. So 1 and 0. So 1 and 0 in OR gate is what? 1 and 0 in OR gate 1. Right. So 1, but here not is there. So 0 will come out. Okay. Here AND gate, this is 1, 0. Okay. 1, 0, 0 and whatever. Okay. So 1, 0, 0. But not gate is not is there. So 0 not 1 will become. Okay. 0 and 1 AND gate. So 0. Okay. So this answer is also coming 0. Okay. Okay. Fine. Now next take 0, 1. Okay. So 0, 1 I think it will work similarly. But let's see. So 0, 1 if we take. So A is 0, B is 1. So 0, 1, 0, 1 AND gate. Right. 0, 1 what will give me? OR gate 1 and 1 not is there 0. Okay. Here AND gate is there. So 1 and 0. This will give 0 and then not is there. So 1. So 1 and 0 through AND gate 0. Okay. So this is also 0. That's it. Next 0, 0 if we take. Okay. 0 and 0. So 0, 0 OR gate 0 and not is there. So 1. Okay. Here 0, 0 AND gate 0 and not is there. So what will become? 0, 0 AND gate is there. So 0 and not is there. So 1. Okay. 1, 1 through AND gate. So 1. Okay. Then it's 1. See the truth table and then try to answer. Which are the option? OR gate, AND gate, NOR gate, NAND gate. Okay. Here if I see the logic, 1, 1 is giving me 0. Okay. If I see by the AND gate, it is exactly opposite of OR gate. Okay. 1, 1 should give me 1. He gave opposite. Okay. 1, 0 should give me OR gate. According to OR gate, it should give me 1. So he gave opposite. 0, 1 he should give me 1. So gone opposite. 0, 0 should give me 0, but he gave 1. Right. So this is NOR gate. Okay. This is what? NOR gate. Second option. Okay. This much you should know. Okay. Generally this is solved also, but I will not recommend to remember, because the problem is how much you will remember. Okay. So solve, not an issue. Okay. If the paper is hard, it is very good if you don't make any silly mistake and you solve on the question which you are able to solve. Give time on that. Okay. 26th. An oxygen cylinder of volume 30 liter has 18.2 moles. This question was very lengthy calculation. Okay. Very lengthy calculation. Okay. 30 liter has 18.2 moles of oxygen. After some oxygen is withdrawn from the cylinder, moles are taken out. Okay. Its gauge pressure drops to 11 atmospheric pressure at temperature 27 degrees centigrade. The mass of the oxygen withdrawal from the cylinder is nearly equal to. Okay. Volume is 30 liter. Cylinder is there. So volume is 30 liter constant. Okay. Initially mole was there 18.2. Okay. After some oxygen is withdrawn the cylinder, its pressure, gauge pressure is 11. So original pressure is how much? 12. Gauge pressure plus atmospheric pressure is the normal pressure, the pressure that exists at that particular moment. Okay. That is 12 atmospheric pressure. Temperature is 27. He is saying. So pressure and temperature he gave. Volume already 30 liter is given. Okay. R we know. So we can find out the number of moles. Final number of moles we can find out. Then he is asking mass of the oxygen, that we can calculate. Just see how. I know PV equals to nRT. Okay. PV equals to nRT. I am applying at the end. Okay. Number of moles remaining on that. Okay. So nR I am writing. So nR is how much? PV by RT. Pressure is how much? Pressure is here 11. So actually this is 12. Okay. and here this is 100 by 12 joule per mole per Kelvin, right? So pressure is 12 into in ATM. So ATM to convert, if you do 1.01 into 10 to the power 5. Okay, 1.01 into 10 to the power 5. This is pressure, and volume is how much? Okay, volume is how much? 30 liter. So 30 liter also you can convert, right? 30 liter into 10 to the power 3. This will come in meter cube. Okay, liter to meter cube, I think you know. 1 liter equals to 1 meter cube equals to 1000 liter. Okay, so by that, if conversion we go 30 liter, right? So liter minus 3. Okay, that's it. Divided by RT. R value is how much? Now R value you will get correct. 100 by 12. Okay, how much? 100 by 12. And temperature 27, so means 300. Okay, from here you will get NR. Okay, this is calculation, very dirty calculation, I will not do. Okay, NR you will get. Okay, now what you have to do is NR, this is the N total. N total is how much? First of all, N total is how much? N total is how much? 18.2. 18.2. This is N total. Okay, this is NR remaining. Okay, means how many you withdrawn? Number of moles withdrawal. That is how much? I can say N total minus NR. Okay, this is the number of moles. If I want to get mass, mass is what? Number of moles into molecular mass, right? So number of moles is NW. Okay, into molecular mass is oxygen is 32. 16 into 2, right? 32. From here NR you get, NTs you have, so you will get NW. NW into 32 is your answer. Okay, that answer will come in grams. Okay, that answer will come in grams. You have to answer in kg, so divide by 1000. Okay, divide by 1000. Okay, calculations are there. Okay, there are chances we can make mistake. So this was the question you have to leave. Student who have wasted on the time on this question have lost too much of time, right? So this was the learning, that if the paper is difficult, you have to learn that which question to leave, which question to solve. Okay, question is easy, but there are many possibilities where you can make a mistake. Okay, or you will not able to click that how to solve. Okay, question is not that much hard. Okay, calculations are hard. Okay, so I will leave this question. Okay, so that you have to understand where to leave, where to not leave. Okay, and if it is this I have told in other lecture when we gave the strategy to crack the JEE, the NEET also, there I said that if question is taking more than 15 seconds to think, then leave it. Okay, that was way. Okay, so some people don't listen, they think that we can do all the questions because we have to score 700 plus or whatever 650 plus. Okay, there also you have to understand that first you have to leave and then come back and then solve. Okay, this is the way. Got it? Question number 27. In a certain camera, the combination of the four similar thin convex lenses are arranged axially in contact. Then the power of the combination and the total magnification of the compression of the power P and magnification M for each lens. So each lens power is P, so total power is 4P and magnification is M, so magnification multiply. So M to the power 4, first option, 4P and M to the power 4 directly. Okay, we know already. Power will be getting added and magnification will be multiplied. Okay, if you take combination, so this is directly answer came, first option. 28th, two gases A and B are filled at a same pressure in separate cylinders with movable pistons of radius RA and RB respectively. On supplying an equal amount of heat to both the systems reversibly under constant pressure. Supplying equal amount of heat at a constant pressure. Okay, this is main thing. Like actually information is everywhere in the question. Okay, so you have to read and get out, take the information one by one. The pistons of the gas A and B are displaced by 16 centimeter and 9 centimeter. Okay, so piston is displaced by 16 and 9 with the A cylinder is displaced 16 centimeter and B cylinder is displaced 9 centimeter. If the change in their internal energy is same, then the ratio is okay. Understand? Change in internal energy is also same. Okay, Q is given also same. We know Q is equals to delta U plus W. Okay, Q is same, delta U is same, means W is same. Okay. Constant pressure, what is the work done? Constant pressure work done, P delta V, change in volume in A part and P delta V in the B part. Okay. And he said pressure same. Okay, initial pressure same and constant pressure you are doing, so pressure is same in both the sides. So pressure is also cancel out. So change in volume is only the thing here, delta VB. Okay, change in volume, how you will write down? Circular piston, okay, moved 16 and 9 centimeter in both the cases. So I can say 16 with RA case. Okay, so how much is the change in volume? This only, na, increment. From here piston move outward 16 centimeters. So length change 16 and area of crossing. Area of cross section into length is the volume. Okay, so here you can say pi r square into 16. Don't change the unit, here centimeter, here also centimeter will come. RA, and here pi RB square into 9. Got it? Okay. So RA by RB will come what? I can say 3 by 4. That's it. 3 by 4. 3 by 4. 3 by 4. Fourth option. Okay. That's it. Q was same, U was same, internal energy change was same, so work done is same. Work done is P delta V in the case of constant pressure. Okay, so P is also same, so delta V same. So delta V is what? Area of cross section into volume, length, move, piston moved, right? So that's the volume change. That's it. This question was easy if you are able to click, otherwise you can leave also. Okay. 29th. A balloon is made of an material of surface tension S and its inflation outlet from where gas is filled in it has a small area A. Okay. It is filled with a gas of density rho and takes a spherical shape of radius r, and the gas is allowed to flow freely out of it. The radius r changes from capital R to 0. Okay. Basically, that gas is flowing outward and radius is decreasing, and in t time all the gas flows outward. If the speed is v of the gas coming out of the balloon depends on the radius, and as R alpha, RA, okay, and here T is depends on S of alpha, where S is the surface tension. Okay, he mentioned here A to the power beta and density to the power gamma and radius to the power delta, like this. Then what is the, so actually I can say delta and alpha are same only, delta and A are same only. Okay, so first of all delta and A are same. Okay, so here by that I can say delta and A, radius, and here density, area. A is the area, right? A is the area of cross section, R is the radius. Okay, so, and he is asking coming out of the balloon depends on the VR. Okay, fine. Velocity, VR on the gas coming out of the balloon depends on R as R alpha. Okay, fine. So this is the T. Okay. So time. Okay. So he is saying what? Time depends upon surface tension to the power alpha, S to the power alpha. Okay. And then A to the power beta, A to the power beta, where A is the area. Okay, if you read here, has a small area, capital A. Okay, and density to the power gamma, density to the power gamma, and here R is what? Radius. Okay, R to the power delta, R to the power delta, sorry, okay, delta. Got it? These are the things. Okay, now solve for these things first of all. Okay, first hand. So what we say, time, this is time, right? So time is T to the power 1. Okay, M0, L0, right? M is also 0, L is also 0. Here you can say proportional surface tension. Surface tension is what? Surface tension I can say force per unit length, right? So force is M and L T to the power -2. Basically this to the power alpha. Area means length square. So L square to the power beta, and density. Density is what? Mass, length to the power -3 to the power gamma, and delta is nothing but length to the power delta only. Okay, that's it. From here, if I compare, mass is what here? Alpha, and here delta. So I can say alpha plus gamma is equals to 0. This is one equation. Length equation, if I see here 2 beta and here minus 3 gamma. 2 beta minus 3 gamma, okay, and plus delta equal to length is also 0. Okay. Third, time is minus 2 alpha, okay, and here that's it, minus 2 alpha is equals to 1. Okay, so alpha equals to alpha equal to minus 1 by 2. Alpha came, put the value here, so delta came, sorry, gamma came. Gamma is 1 by 2. Okay, gamma 1 by 2 and alpha minus 1 by 2. So gamma and alpha came. Now by this hit and trial, you put the value of beta and delta. Okay, beta and delta will come by hit and trial. Okay, by checking the option you can do. Okay, so gamma you know 1 by 2. Okay, so beta and delta you go with the options. Okay, so when going with the option you will get it. Okay, so I told you this thing, that this is minus 1 by 2, 1 by 2. Okay, so beta and delta, if you put by the options, you go by the options. Put the options, beta and delta. Beta ones take minus 1 7 by 2, minus 1 3 by 2, minus 1 by 2 7 by 2, and minus 1 5 by 2. Okay, only this condition will satisfy here. Okay, so that's it, first option came answer. Okay, that's how answer will come, by the unit and dimension. Okay. Next, this question was very easy. Okay, circular motion question. A bob of heavy mass m is suspended to a light string of length L. The bob is given a horizontal velocity v naught as shown in the figure. If the string gets slank at some point P, slank means tension got 0, right? So who is providing centripetal force? mg component. Okay, that's it, that we have written in the notes. Okay, if the string gets slank at a point P making angle theta from the horizontal, the ratio of the speed of v bob at a point P to its initial speed VO. Okay, so here is speed VP or V only you assume. Okay, let's solve this. What he is saying, at this point speed is VP. So basically towards the center, I can say mg is this side. Okay, with the horizontal making angle theta, right? With the horizontal. Okay. So making horizontal with the theta. So this will come mg sin theta. mg sin theta. Okay, mg sin theta is providing the centripetal force. So mg sin theta, tension got 0, right? Just got 0 here at this point. So mg sin theta equals to mv square by r. This is mv square by r. Okay, and second equation, from where it will come? Second equation I can say work energy theorem, right? So work energy theorem, if the particle was here, he was going with VO, okay, and rotated and went here. Okay, so if we assume the radius is r or length, radius r, this, okay, let's call this as r, capital R. Okay, so work done is how much? Negative work done how much? mg into r plus, this is r sin theta, right? Okay, is equals to change in kinetic energy. Change in kinetic energy final how much? Half m v square here. Okay, and here initial was half m v naught square. Okay, that's it. Got it. So what you do, m got cancelled out. First of all, from here you can say rg sin theta is equals to v square. Okay, and from here you can say m got cancelled out. Okay, so what you will have, and negative also you take that side, so you can say g r 1 plus sin theta is 2, also you bring this side. Okay, so you will have v naught square minus v square. Okay, and v square is rg sin theta, you can put here. Okay, so if I put here, what you will get? VO square is equals to 2gr plus 2gr sin theta. This is already here. Okay, and v square will also come, that is rg sin theta, right? So this will become 3. Okay, this will become 3 factor. Okay, v square you bring, v square from here you put. So this is your came VO square. Okay, and v square is already there. So what you will write down answer? The ratio of the speed v of the bob at point P by VO. So V by VO, you have to answer V by VO. Okay, so V is that. Okay, take under root also. So under root we will take later on. RG sine theta divided by this is 2GR plus 3RG sine theta. Okay, to the power half. So RG get cancelled out. So you can have sine theta, and denominator you will have 2 plus 3 sine theta to the power half. Okay, sine theta upon 2 plus 3. Okay, so here second option. Actually they didn't mention here power half will come. Okay, there is a power half. Okay, second option they mention here wrong. Okay, printing mistake. Okay, here half is there, sine theta upon 2 plus 3 sine theta. Okay, that's it. So second option. One equation directly here, mg sine theta component is providing a v square by r, and second equation, work energy theorem between this point and this point. The answer came. That's it. Very easy. This question was the easiest question possible in the paper. Okay, percentage error calculation, right? So we know for percentage error we go for the positive. Take ln and differentiate. That's how you do percentage error, right? So first of all, let me write down what is given equation. P equal to a cube b square. A cube b square divided by c root d. C root d. So here you can say a cube b square c to the power minus 1 d to the power minus half. Okay. So if you take ln and differentiate, negative will come, but we are going for the error, so error we take positive only always, right? So delta p by p is equals to 3 times of delta a by a plus 2 times of delta b by b. ln and differentiate. Okay, plus minus will come, but in error calculation plus will come. Okay, so here you can say delta c by c plus half times of delta d by d. Okay, so here percentage error, add 3 times of delta a by a. Percentage error in a is 1%, 3%, 2%, 4%, 1, 3, 2, 4. Okay, 1% plus 2 into b have the error 3%. Okay, plus c have the error 2%. Okay, plus half into d have the error 4%. Okay, this is 3 plus 6 plus 2 plus this is 2, right? So how much is this? 6, 3, 9, 9 plus 4, 13. This is 13%. So total error is 13%, first option. Okay, that's how answer is coming. Okay, got it. Next question, 32. Sun rotates around its center once in 27 days. Okay, so sun is rotating by himself like this. Okay, in 27 days, one complete rotation. Okay, basically its time period is 27. What will be the period of revolution if the sun were to expand to the twice of its present radius without any external influence? Assume the sun to be a sphere of a uniform density. Remember, we have seen a video also, if you find out on YouTube, there is a plastic kind of sphere, okay, that shrinks and that expands, then its omega changes, right? That kind of thing here happening, okay? What is that? Angular momentum conservation, right? So simple angular momentum of conservation, I can say I omega is equals to I dash omega dash. Okay, moment of inertia initial, I can say solid sphere, so 2 by 5 m r square. Okay, and omega is 2 pi by time period, right? So 2 pi by time period. Time period is 27 days. Okay, answer will come that side also, 20 days only answer will come. I dash is what? 2 by 5 2 by 5, mass same, radius became double as you are saying, and 2 pi by time period t dash. Okay, that's it. Answer came. Okay, from here 4 factor, so this t dash is nothing but 27 into 4 will come. That's it. Okay, so 27 into 4 is how much? I can say your answer, second option, 108. Okay, 27 into 4, 108. Okay, that's it. Angular momentum conservation, it will expand, so is omega will reduce, so time period will increase. Okay, that way only. Hint is here. Sun we have to expand present radius without any external influence. Without any external influence means, what is that? External torque 0, so angular momentum conservation. 33. Radius of Martian orbit, means Mars orbit, is around the Sun is 4 times of radius of the orbit of the Mercury. Okay. The Martian year is 687 Earth days. Okay. So Martian year is 687 days. Basically its time period is 687 days. Okay. Then which of the following length of the year is of Mercury? Okay. Now go in the Kepler's law. Okay. Kepler's law says T square is proportional to R cube. Okay. So I can say time period is some constant times of R to the power 3 by 2. Okay. Like that I can say. So for the Mars, okay, for the Mars when you are writing, what is the time? 687. 687 is equals to that constant K as it is you keep, and radius is, Mars radius is 4 times, right? Yes. It's 4 times of radius of the orbit of the Mercury. Okay. So 4R to the power 3 by 2. Okay. Next, for the Mercury you write down some T number of days. Okay. Is equals to that constant same. Okay. Constant is constant and R to the power 3 by 2. Divide both of them. T will come how much? I can say T is 687 by 4 to the power 3 by 2. That is 2 to 2 cube 8. 687 by 8 you can do. Okay. This will give you the answer in number of days. Okay. Approximately it matches with 88. Approximately. Okay. So obviously perfect answer is not there 4 times. So that's why approximately 88. There is no one is close to that. Okay. So 88 it will match. Okay. Third option. Okay. I think divide by 8 you can do easily. 687 by 8. Okay. So that will give you approximate 88 answer. Okay. Next question 34. A wire of resistance R is cut into 8 equal pieces. This was also very easy. Okay. 8 equal pieces means R, resistance is R and 8 equal pieces. So resistance became how much? What? R by 8, R by 8, R by 8 like this, right? Okay. Directly proportional to length. Okay. So length became R by 8. So that's how. From these pieces, 2 equivalent resistance are made by adding 4 of these together in the parallel. Okay. 4 together in the parallel like this. Let me draw the diagram, then you will understand better way. And then ahead he is saying something else. Then these 2 sets are added in series. The effective resistance of the combination is like this. 1 resistance, 2 resistance, 3 resistance, 4 resistance. These are in parallel. And then next, again the same combination. 3, 4, like this. Okay. Every one is R by 8. Okay. R by 8, R by 8, R by 8. These are R by 8. Okay. So here if you find out R equivalent, so I can say 1 by R equivalent is equals to, you will write down R by 8. So 8 by R 4 times you will write down. Okay. So this R equivalent will come here of this combination. One combination will come R by 32. Okay. Here this is total R by 32 and this is also R by 32. Series now R by 32, R by 32 series. So this will give me R by 32 plus R by 32. That is nothing but R by 16. So answer is R by 16. First option. Okay. Divide in 8 pieces, 8 equal pieces. R by 8, R by 8, R by 8, R by 8. R by 8, R by 8, R by 8, R by 8. Parallel connection combination 1 by R equivalent equals to R by 8. So 8 by R, 8 by R, 8 by R, 8 by R. 4 times, right? So this becomes R equivalent is R by 32. Okay. R by 32 here. This is R by 32. This is R by 32. Now both are in series combination. That's how. Okay. Next, 35. A photon and an electron have the same energy E. Okay. The ratio of lambda of their de Broglie wavelength is, okay, de Broglie wavelength ratio. Fine. You can say lambda is equals to, E is equals to hc by lambda first of all. Okay. Okay. And next what? Lambda is equals to h by p. Okay. This is for the electron, you can write down. Okay. This is for the photon. Okay. For the photon and electron only is asking, na? So for the photon, you can write down this. So lambda photon is what? hc by e. Okay. And here this is p, and we also know that E is equals to p square by 2m, right? So p is equals to what? Under root of 2me. Okay, that value if you put here, lambda e came how much? H upon under root 2me. Okay, now he is asking lambda of photon by lambda of electron. Lambda of photon by lambda of electron. So lambda of photon is what? hc by e, and lambda e is what? H, and this is 2me. Okay, h got cancel out. Okay, c is in multiply, and then under root of what you have? 2m in numerator and e is in denominator. Okay, c upon c into 2m by e. Okay, c into 2m by e. First option. Got it? That's all. Just nothing but formulas. One formula I know for the photon directly, and for the electron I know E lambda equals to h by p, and where p is nothing but E equals to p square by 2m, right? Always valid. Okay, by that I can say. Okay, so both lambda came, energy same, divide. That's it. Answer came. Easy, right? Next question. A sphere of radius r is cut from a larger solid sphere of radius 2r as shown in the figure. Okay, the ratio of the moment of inertia of the smaller sphere to that of the rest of the part of sphere about the y-axis. About same y-axis we are writing. Okay, so this question was in the notes only. Okay, see how. Okay, let's draw sphere. Here is sphere, and this total radius is 2r. Okay, for the bigger one 2r. Let's assume that bigger one have the mass capital M. Okay, so this sphere is made, or you can say this plus the small sphere is giving me of, which is of radius r, is giving me the complete sphere. That's how we solve superposition thing, right? So moment of inertia of this I don't know, but this I can calculate, that I can calculate. Okay, this mass is m. Okay, so this mass will be how much? Can I answer? Okay, if you have studied in the notes. Okay, so here density, what you can write down? Rho is equals to mass upon volume. Volume is 4 by 3 pi 2r cube. Okay, understood? So here m1 you will write down how much? M1 you will write down what? M1 how much? Density, that is m upon 4 by 3 pi r cube, that is 2r. Okay, basically 2r cube into volume of this. Volume of this is 4 by 3 pi r cube. Okay, so this is 1 by 8 factor. So m1 is nothing but m by 8. So here mass is 7m by 8. Doesn't matter, leave it. Okay, that's it. Now moment of inertia, the final calculation is what? Moment of inertia, right? So let's calculate that moment of inertia. Okay, how you will calculate? Let's assume this moment of inertia is IR, moment of inertia of remaining mass. Okay, this moment of inertia, how you will calculate? About this axis you have to calculate. Okay, so about the, from the passing through the center, I know what is the value of that. I can say what is the value of that? Mass 2 by 5 mr square, right? So 2 by 5 m, mass is m by 8, 2 by 5 m r square. Okay, plus if I moving this side, md square, ICM plus md square, right? So md square is how much? M is m by 8 into d, distance is what? R, right? So r square. This is the moment of inertia of this small part. Okay, about the y-axis. Okay, and about for this, what you will write down? Directly 2 by 5 and radius, mass is m and radius is 2r whole square, right? 2 by 5 mr square. This is the moment of inertia of the complete sphere I. Okay, now from here you can write down what? You can say IR by the superposition, IR plus IS is equals to I. Okay, so IR is nothing but I minus IS. Okay, so you write down the values. I is how much? 2 by 5 and 4 to the 8. Okay, so 8 by 5 mr square and minus is. Is is how much? This here, if you see, this is how much? Mr square. This is 4 5 4 20. Okay, and this is mr square by 8. Okay, that's it. So from here you can take the LCM. What? 40 you can take, I think. Yes, 40. Okay, so 40 LCM if you take, what you will get here? 8 times 8 just 64. 64 mr square. First of all you take common, mr square common. Okay, and 40 LCM. So you can write down here, it's 64. Okay, minus 2, and this is 5. Okay, 7. 64 minus 7, how much? 4 3 60 57. 57 mr square by 40. Okay, I think correct. 2 correct. Okay, so this is IR. Okay, IR. Now what he is asking? What he is asking? He is asking me the moment of inertia of smaller sphere to that of the rest of the part. So moment of inertia of the smaller sphere. Smaller sphere means this thing. Okay, so IS also let's calculate separately. So this is IR to the IS. IS is what we calculated here, that is mr square by 20 plus mr square by 8. That is how much? I can take the LCM, how much? 40. Okay, mr square common and LCM is 40, and you can say here this is 2 and 2 plus 8, that is 5. So this is 7 by 40. Okay, 7 by 40 mr square. Okay, IS is nothing but IS is nothing but 7 by 40 mr square. Okay, so one is 57 mr square by 40 and this is 7 by 40 mr square, right? So IR by IS he is asking. No, IS by IR. He is asking IS by IR. Okay, so I can say IS is what? 7 by 40 factor, and IR is what? 57 by 40 factor. So answer is 7 by 57. 7 by 57, first option. Okay, this question is done in the notes. Okay, this question is done in the notes, but actually in the notes question, when you will see here, you will see what? Here this original sphere radius we have took r, and the smaller sphere will come r by 2, like that. So there is just a factor of 1 by 2. Okay, by that calculation wise it is different. Otherwise if you solve taking that also, it will come same answer. So this is notes question. Okay, this should be doable. Okay, this should you have done. Okay, next 37. Electron mass and charge is given. Moving with a speed c by 100. C is what? 3 into 10 to the power 8. Okay, is injected into an magnetic field B of magnitude. Okay, magnetic field is given perpendicular to the direction of the motion. Okay, perpendicular to the direction of the speed. Okay, so I can say he will experience a force. What is that value of force? Okay, what is that value of force he will experience? I can say that will be, force will be how much? Q into V cross B. Okay, and V or B are perpendicular to each other. Okay, that's it. So this is the force he will experience. We wish to apply an uniform electric field E together with this magnetic field so that the electron does not deflect. Okay, so the speed of the light C is 3 into 10 to the power 8. So what is the direction of electric field and the magnitude is asking. Okay, first of all, if you understand, okay, what we can say, due to this force, what will happen if this have a velocity speed V, okay, that is c by 100, we will put the value of later on. He will experience, if magnetic field is, let's say, coming outward. Okay, so I can say V cross B. So V cross B, this side, force he will experience this side. Okay, but B is which side? Outside the B. Okay, so force is experienced this side, this force is this side, right? So you have to apply electric field this side, so that Q into electric field, it will come this side, force will come this side. Okay, so magnetic field is outside, electric field is this side. Okay, then it will balance. So I can say magnetic field and electric field should be perpendicular to each other. Okay, so that's how. So first of all, perpendicular, that is solved, right? Electric field and magnetic field should be perpendicular. Okay, how much is the value, that you have to understand. For that, understand Okay, let me not rough this. Okay, let's take this thing as this side in the corner. Okay, now this force should be balanced. So first of all, this is V cross B, but both are perpendicular, so 1, sin theta 1. Okay, so Q into VB is equals to Q into E. Okay, is it electron? Electron. So negative charge is there, means everything will be opposite direction. Okay, don't mess up with this. Electron means just opposite direction. Okay, the force will become this side, so E into Q, you have to apply this side. That's it. Okay, so VB equal to E. Okay, so electric field is nothing, V into B. So V is what? C by 100 into B. C is what? 3 into 10 to the power 8, and this is 100, so 10 to the power minus 2. Okay, into B. B is how much? Magnetic field 9 into 10 to the power minus 4. 9 into 10 to the power minus 4. Okay, so this is 9 3s are 27, and this is my 6 minus 4 2, 10 to the power 2. So 27 into 10 to the power 2. 27 into 10 to the power 2 and perpendicular. So this is fourth option. Okay, this is notes question again. Okay, if you remember, we have gone little bit higher order also with a helical path. Okay, so this is very easy question. Okay, this is you have answered this question. Okay, very easily. This kind of question in the module even 29th. Electric field in the plane electromagnetic wave is given by. Okay, so if you see, we already know that what E by B is giving me the C, right? E by B is the C. E by B is C. So what I want the B, so E by C, right? So E is what? How much? E is given as 60 cos, right? So 60 cos of whatever function here it is divided by C, that is 3 into 10 to the power 8. So this will become 2, and this is minus 8 plus 1 minus 7. 2 into 10 to the power minus 7, and cos of same function will come. Okay, as the electric field, 2 into 10 to the power minus 7 into cos of the same function. So third option. Okay, because we know this thing, E by B is C. Okay, by that you can solve directly very easily. Okay, or you have observed from the options also, there is a 3 into 10 to the power 8. So you have to go with which option. Okay, what thing? C, this E by B equal to C. Next, 39. A body weighs 48 Newton on the surface of the earth. Okay, the gravitational force experienced by the body due to the earth at a height equal to 1/3 of the radius of the earth from its surface is. So if it is going little bit higher, how much? 1/3 of the radius, r by 3 above the earth. So r plus r by 3 factor. Okay, see, 48 Newton is the force experience, right? 48 Newton is mg. Okay, so that from here I can say m is equals to what? 48 by g. G is changing, m is constant, na? M I took. Okay, next, new mg, new force experience is m into g dash. This g dash I have to write down. So m into g dash is how much? G dash I can say g m. Let's write down first g dash only. G m by r plus r by 3 whole square. Okay, that is how much? So this is 4r by 3, so 9 by 16. Okay, 9 by 16 gm by r square. Okay, so g dash is nothing but 9 by 16 times of small g only. Okay, so now the new force experience, that will be m into g dash. Okay, this m is how much? 48 by g. Okay, and the g dash is how much? 9 by 16 g. Okay, so g got cancelled out. 16 3, correct? 3. So this is 3 into 9, that is 27 Newton. Answer. Okay, new mg is what? M into g dash. M doesn't change, right? If you change the planet even, m will not change, but g will change. Okay, so gravity changed by this factor. So I wrote. Okay, so 27 Newton is the answer. That is fourth option. Okay, understood? It is taking lot of time, that you have understood that the paper is very lengthy. It is not he didn't give formula based questions or anything, something like that, very easy that he should give, but what to do? Okay, you have to deal with it. An unpolarized light beam traveling in air is incident on a medium of refractive index 1.73. 1.73? Root 3, right? Correct? At Brevister's angle. Then both reflected and transmitted light wave are perfectly polarized. No. Okay. We know that reflected wave is polarized at the Brevister's angle. Remember this thing. We have studied this thing. See. If the light ray is coming like this, okay, at an angle theta, okay, it will get refracted, okay, inside, and there will be a reflection, okay. These both are perpendicular to each other, that we say Brevister's angle, okay. So if these both are perpendicular, then this get polarized, okay, reflected get polarized. So this is theta, so reflected angle is also theta. This is 90, this is theta, so this is 90 minus theta, okay. Now here you apply the rule, so I can say 1 into sine theta is equals to mu into sine of 90 minus theta, okay, that is cos theta, so sine theta by cos theta, tan theta equal to mu, that is given 1.73, means root 3, tan theta equal to root 3 means theta equal to 60, approximately 60, because 1.732 or exactly root 3 was given, then you have root, because root 3 is an root 3 is not given an exact value, right? So I can say 60 degree approximately. So here third option will satisfy. Reflected light is completely polarized. Reflected light is completely polarized. Okay, that we have studied in the Brevister's angle, and the angle of reflection is close to 60 degree. That is correct. Okay. So here I think all other three option is 30, 30, 30. There only it got rejected. Okay, you don't have to go in the reflected is polarized or what is polarized. Go with the angle only. By that only you got third option. Okay. 41. This question was easy. Okay, I will consider this as easy. Little bit of calculation, but easy. Constant voltage 50 watt is maintained between the 2 points A and B in the circuit as shown in the figure. The current through the branch CD. Okay, this question is solved. Okay, CD of the circuit is 1324. Okay, fine. This way, like this. 1324, 1324. Okay. 1, 3, 2, 4 ohm. Okay, like this. And now calculate the resistance first of all, equivalent resistance, and calculate the current. Okay, so well, voltage battery is 50 volt. Okay, so battery voltage is given 50 volt. Okay, that's it. This much is given. 50 watt. So resistance, equivalent resistance, these are in parallel. 1 and 3 parallel means how much? I can say 1 into 3 by 1 plus 3, 4, and here plus this and this combination in series. So this, for this parallel combination, 2 into 4 by 2 plus 4, 6. Okay, so this is R equivalent. Okay, this R equivalent will come how much? 3 by 4 plus 4 by 3. Okay, so how much is this? 9 plus 16 by 12. Okay, R equivalent, that is R equivalent is 25 by 12. Okay, 25 by 12. So V, that is 50, is equals to I into R, that is 25 by 12. Okay, so I is equals to 24 ampere. Current flowing here is 24 ampere. I is equals to 24 ampere. Okay, understood till here? 24 ampere. R equivalent I calculated, 24 ampere came. Now understand. Let me send this part other way. If you have understood this thing, I can send it this side. Later on, if you want, you can look at. Take a screenshot if you want. Now only. Okay. See now. I came 24 ampere. Okay. Now I know through this wire how much current will flow. You know that if two resistors are in parallel, that how much current will flow through this one. If I call this I1, how much the I1 will? Okay. I can say I1 will be 24 into inverse ratio of resistance. So means 3 by 4. Okay, 3 plus 1, 4. So by that. So I1 will come how much? 3 by 4, 24, 4, 6. 6 into 3, 18 ampere. So here I1 will flow 18 ampere. Okay. This is 2, 4. So this is coming this side, this is coming this side. Let's name this as I2. Okay. Why I am calling that? Why I am finding out that I will reply later on. Okay. Just understand. I2, you will understand later on. I2 is equals to 24 into inverse ratio. These are also parallel combination, right? So inverse ratio of the, what we say, combination, right? So inverse ratio means 4 by 4 plus 2. Okay. This is the factor. So I2 is how much? 4 by 6, that is 2 by 3. So 24 into 2 by 3. So that is 8, 8 to the 16 ampere. Okay. So this is nothing but 16 ampere and this is nothing but 18 ampere. So I can say 18 is coming from this side. Okay. And this side 16 is only going. Means rest 2 is going this side. Na? That's why I find it out. Okay. Coming from this side 18 and going this side 16. So this side how much? 2. So that's what 2. So answer is 2, fourth option. Okay. Equivalent resistance, net current, parallel combination used, inverse ratio of their resistance. It divides the current, right? That's it. That's how you solve. Done. 41, 42. The plates of parallel plate capacitor are separated by D. Two slabs of different dielectric constant K1 and K2 with thickness 3 by 8 into D and D by 2 respectively are inserted in the capacitor. Due to this, the capacitance becomes 2 times larger than when there is nothing between the plates. Okay. And K1 K2 relation is also given. So K1 K2 relation we will use later on. First, what he is saying. Normally you say capacitance formula is A epsilon naught by D. Okay. But he is saying capacitance is becoming 2C when A epsilon naught is A epsilon naught only. But here you have thickness added what? 3D by 8 with K1. Okay. And D by 2 with K2. Okay. So how we write down that factor? D minus write down 3D by 8. 3D by 8. Okay. And minus D by 2 also. And 3D by 8 minus. So plus 3D by 8 K1 and plus D by 2 K2. Like this. Like this you do, right? Okay. This is the new capacitance, right? So C value, first of all, you can put A epsilon naught by D. Okay. And you can have that factor cancel out. Okay. If I solve here, C value A epsilon naught by D, if you put, okay, what you got? 2 times of A epsilon naught by D. Okay. This equals to here A epsilon naught, and here this D common. Out of this you will have 1 minus 1 by 8 minus 1 by 2 plus 3 by 8 K1 and plus 1 by 2 K2. Okay. See here ahead what I can say, A epsilon naught D, A epsilon D, cancel out 2 here. Okay. So 2 you bring that side and this whole thing this side. Understand this thing? This whole factor bracket this side and 2 that side. So you will have that side 1 by 2. So 1 by 2 is equals to, or you reverse you can say. Okay. So 1 by 2 equals to 1 minus 1 by 8 minus 1 by 2. Okay. This is 3 by 8 K1. Actually, if you read question, you have to find out K1 only. Okay, so K2 you can replace. K2 is what? K1 by 1.25. So K1 equals to, you have given K1 equals to 1.25 into K2. So 1.25 is nothing but what? I can say 125 by 100. That is 5 by 4. Okay, so K2 is nothing but 4 K1 by 5. Okay, so K2 value I can put here. What is that? Plus 1 by 2 into K2 is 4 K1 by 5. By 5 means 5 will go in numerator. Okay, that's what. Here next, 1 by 2 you keep, or 1 by 2, what you do? All these things you bring this side. Okay, so what you will have? 1 by 2 plus 1 by 2, 1. Okay, this 1 by 2, 1 by 2, 1 cancel out, minus 1 by 8, this side 1 by 8. Okay, and this side how much? This is 3 by 8 K1 plus 5 by 8 K1. Okay, So this is here also what we can say, 3 by 8, 5 by 8, common, okay, common what you will take, 8 k1, 3, 8 k1, okay, so this is 8 by 8, 1 by k1, okay, so k1 equal to 8. Third option, 2.66. okay, fine, there is something wrong, 2.66, but we have made somewhere mistake, okay. So if we analyze, actually here from 1 by 8, 3 by 8, actually I did 1 by 8, okay. So here this is 3 by 8, okay, so nothing changed, thus here 3 by 8, so this is 3 by 8, okay, here. So here when you will solve, okay, for k1, so this is k1 will come how much, 8 by 3, so this is 2.66, okay, that's how it comes. So I made just small mistake here, 3 by 8 factor, okay, that you have to change, that's it, okay. So answer is third option, 42. Next 43. 43 you have vernier scale. This also he gave little bit difficult, that you don't study generally, okay. I think NEET people avoid this thing, this x equal to 0.1, okay. Okay, consider diameter of a spherical object being measured with the help of a vernier caliper. Suppose its 10 vernier scale divisions are equal to 9 main scale division. This everyone knows, okay. Generally we take this only, okay. So means 0.1 factor, right? Okay. Least division of the main scale division is 0.1. So 0.1 into this is 0.1. So 0.01, okay. Then vernier scale are close to. The main scale reading of diameter is 5 centimeter, okay. So I can say 5 and number of coinciding vernier scale divisions is 8. So 8 into, so I can say how much will be your answer. Coinciding is 8, right? So 5, okay, plus you can say 9 scale, so 0.1, and then he said this is 0.1, so 0.01, so 8 into 0.01, so this is, and then so this came how much, 5.08, okay. But there is one more problem, okay, there is a mismatch of 0.1, okay. So adjust that. So your length, actually vernier scale, you had a mismatch, you can call it like this, okay. When you study vernier scale, here there is a mismatch of 0.1, right? So your length is have an error of 0.1 already, okay. So what you will do, this is minus 0.1, okay, minus will come in the measurement, okay, because here there is a mismatch, okay. I think you avoid these calculations, but 0.1 will come. So here it will come 4.98, sorry, 98, okay. That's how it comes, answer 1, okay. So this one thing you avoid, that 0.1 centimeter sometime, okay, because we don't solve that much high amount of questions on this, that error will come, right? But he gave that good question of this from unit and dimension, which was a scoring chapter, okay. From that he gave this question kind of, okay. Otherwise you will take 5.08, but actual answer is 4.98 if you take a error calculation, okay. I think confusion will be there, that the 0.1, this 0.1 should be subtracted or added, because answer is coming 5.08 normal calculations, then answer can be 5.18 also and 4.98 also. So actual answer is 4.98 because it will be subtracted, okay. 44th question. A 2 ampere current is flowing through two different small circular copper coils having radii ratio 1:2. The ratio of their respective magnetic moments is, magnetic moment is what? Current into area, right? Area is pi r square. So radius is square. That's it. Current is same. Okay. So simple this thing here. I is equals to, M is equals to I into pi r square. Okay. I is same. So proportional to r square. So M is proportional to r square. So if radius ratio is 1:2, then magnetic moment ratio will be 1:4. So 1:4, third option, directly. Okay. 45. Okay. This question was like some people are saying very difficult. Actually, this is not that much difficult. Okay. If you understand the differentiation, integration, and little bit of calculation wise, okay, then this question is not that much difficult. See how the curve is like this. Okay. Angle theta is mentioning at the end. Okay. whatever, theta naught. Okay. Now here this is like this curve. Okay. Here if you see exactly, okay, here you have surface tension force. Okay. Here you have surface tension force this direction, right? That surface tension force component will come above, that is T sin theta. Okay. Surface tension component will come T sin theta. Okay. Assume that it is going inside, length is L. Okay. This is, he said, mentioned here. Okay. He mentioned, consider a water tank shown in the figure. It has a one wall at x equal to L. Here there is a wall. Okay. Here there is a wall. This wall. Okay. This is the wall in the z direction, and it is wide in the z direction. So wide, that width only I am saying, consider it L. Okay, that is outside width. Okay, like this, width is L, that is very big, so consider it L. And filled with a liquid of surface tension S, the density rho, the liquid surface makes an angle theta naught, which is very less than 1, with the x-axis at x equal to L. He is saying theta equal to sin theta equal to tan theta equal to dy by dx. Okay, because tan theta equal to dy by dx, so he is saying this is equal to sin theta also, this is equal to theta also. Okay, this we will use. Okay, that's what. Okay, so y by x, now the relation you have to find out. Okay, now T sin theta. Okay, so force will be how much? First of all, force if you write down, then T into L will be there. Okay, TL sin theta, above force will be TL sin theta component. Okay, this component of the force is balancing the whole mg of this liquid. Okay, is balancing the mg of this liquid. Mg, how you will calculate? Density into volume, right? Density into volume. So volume, how you will calculate? Volume, for that length is there this side. If I calculate the area into length, if I calculate this total area into length, that will be volume. Volume into density, that will be the mass. Okay, so area, how you calculate? Area means integration, right? That's it, answer came. See how this TL sin theta, this force is balancing the mg. Okay, mg is what? Density into volume. Volume is what? Length into area. Area is what? Integration of y dx. That's it. Okay, this is only the total area, na? So area into length outside, that is volume. Volume into density, mass. Okay, so this is mass into g. Okay, that's it. Now what you do? Sin theta is theta. Okay, so sin theta is theta. Okay, fine. So TL into theta is equals to, this is rho L g integration of y dx. Okay, actually surface tension, instead of mentioning T, he wrote S. Okay, so let's mention this as S only. Okay, here let's mention it is S. Why to confuse? Okay, L got cancel out. S theta equals to rho g integration of y dx. Okay, now differentiate both sides. Okay, so here what you will have? Here you will have S d theta equal to rho g y dx. Okay, dx you bring this side, d theta by dx. Okay, d theta by dx on S that sides, right? So you will have d theta by dx is equals to rho g y by s. Okay, this is your d theta by dx. Now I know that theta equal to dy by dx. Okay, theta equal to dy by dx. Theta equal to dy by dx. Okay, so here the d theta by dx, again differentiate this. So d theta by dx is equals to what? d2y by dx square, right? Replace this here. So nothing but d2y by dx square is this rho gy divided by s. So d2y by dx square is rho gy by s. Fourth option. That's it. Okay, so not hard. What was the concept here? This force, upward component, surface tension force here. This is length L na outside. This surface tension force component is balancing the mg. Mg is what? Density into volume. Volume is what? Area into length. Length is outside L, and area of cross section is, area is what? Area under the curve y dx. Okay, that's it. Paper was hard, not according to the question, but difficulty of the question in the given time period and given number of questions. Okay, like that. If we count, the paper was, you can call it hard. Okay, hard sense I told, hard is not the questions, but in a given time limit, if you want to solve this question, this many number of questions, it is hard. Okay, so there are certain strategies you should go with when the paper is hard. Okay, and it was expected also, because last year what happened, because of that we can expect that there will be a paper hard. Okay, and it came hard. Fine, it's okay, but preparation you do, everyone is hard, so everyone have lost the marks is okay. If you have wasted the time on the physics, then maybe you will get less score comparison to others. Otherwise everyone have got less. Okay, so just in the hard paper, this is the way that who is leaving the question in a definite amount of time before he started wasting time on that question. Okay, that's the way. Okay, I hope this is done. Okay, thank you, have a nice day.